Enlightening lunch series. So we run about 3 of these a semester, and we bring in different kinds of speakers of interest to our students and faculty. Grad students or students in general, undergrads, you're welcome to stay after the talk is over. We have about 15 minutes to talk with Dr. Brown about professional development, career trajectories, questions of interest. So really, if you're a student, please stay and have a more intimate talk with her about her career and academic life for about 15 minutes afterwards. Just to give you guys a preview, we have 2 other talks scheduled this semester. So on March 22nd, we'll have David Hondala. He is a professor from sustainability who moved into being the future sustainable person for the city of Phoenix. So looking at how you go from academia to doing government policy work. And he'll talk about that journey and his work in the city of Phoenix to mitigate heat. And then on April 12th, we'll have Lauren Ruffin, a new faculty member here in SFIS who is going to be part of the Design Futures team and works on great questions of digital equity in the future. So hope you guys will join us for that. And I'm going to turn it over to Fahim, who's going to introduce Dr. Brown.
Thank you so much, Lindsay. So good to see people twice in a week in person. That's amazing. And with free food, that's even better. So Suzana and I go a long way, and we actually met because she doesn't like trash to be falling around. Long story short, I was in Carnegie Mellon, Rwanda, met with the director there, gave him my business card, and seems like he really liked me, but that's not the case because he kind of threw the card away. It was on the floor. Suzana picked it up, and she reached out to me.
I Googled him.
Yeah, I was legit. So she reached out to me, and I kind of tempted her back to Sony Korea, where I was working during that time. Then I fled. She left, and she thrived. And we've been working since forever, primarily with displaced communities and with community health workers in the different spaces within Sub-Saharan Africa and in South Asia. And for the last 3 years, it was very heart-wrenching, nerve-wracking, but a lot of rewarding as well of working with Suzana in our 3D printed crutch shoe project in the biggest refugee camp in the world, in the border of Myanmar and Bangladesh. So it's absolutely an honor to introduce you here, Suzana.
Thank you. So this project started in 2020. We applied in 2019, and we got a large grant, and we were supposed to start in 2020 and go to this refugee camp that Fahim had contacts with, and then COVID started, and we had to do things remotely. And that was the hard part. That was actually one of the more difficult parts. We couldn't be there on the ground, but we made it work. I don't know, it probably wouldn't be better. We can't compare, right? We cannot do comparative study, but so that's why I called it remote monitoring, because we had to do things remotely. Because Fahim also has Bangladeshi passport, he was allowed in the country during COVID restrictions, and he went, but way into the project. We had to do lots of things remotely. So I will tell you about the journey of the last 3 years, what we had to do to fulfill our promises to our funders and to help actually the refugees that are disabled and live in this camp. Okay, so bear with me. I'll talk for about 30 minutes, maybe 40, and then we'll, okay. So, my name is Suzana Brown, and I graduated in my PhD from University of Colorado Boulder. Most of you know where that is. It was interdisciplinary program in telecommunications, and then you would have to do policy or economics. So since I had an economics business background, I did economics part, and that's how I ended in Rwanda. I was doing monitoring children's malnutrition using mobile phone apps in Rwanda when Fahim came to visit. So this is beautiful Colorado. Looks a lot like here, right? Except we have mountains and not as good weather. And my research interest started with mobile technology for health and education. And that's where I met my friend Christina, who is here. And she's my Rwandan friend. She was working on education. There was, Rwanda is an interesting place to be. There's lots of projects going on and lots of brilliant, a little bit crazy people, right? But then I moved into, when I came to Sony Korea, I started teaching class on entrepreneurship and startups, and then some engineering classes. But my latest research, so that was my research kind of moved into that direction. But my most recent thing is that I've been doing with Fahim was this assistive technology in a humanitarian settings. Most of assistive technology is designed for wealthy countries with paved roads and ramps and wheelchairs and motorized wheelchairs and all the fancy stuff. And we forget that, and I'm going ahead of this. Okay, so in 2020 to 2022, this is my lab, these three handsome guys. But that was just the local thing in Korea. We actually have a lot, and this is this handsome guy. So my biggest collaborator, the most powerful synergy was from ASU. So I'm really glad to be here. This is Fahim and me hiking back in Korea. That remember that?
Don't believe it that I'm out of office.
Yeah, he was. We climbed up this rock. So you know him, so I don't have to talk much about it. I just found this picture. I wanted to remind him that we used to be colleagues. And but this is the whole team. So Fahim was our policy and development person. I was a PI on this project. We had a lead engineer from Greece, and this the three guys that you saw before were my research assistant, designer, and the lab engineer from mechanical engineering. So it was very multidisciplinary. We had engineers, we had development guys, and then we had this person and a couple others that I don't actually have a picture of, who were on the ground, and they were crucial because we couldn't be there. So one thing, and I'll mention that later, we did not foresee, and we couldn't, because that the NGO is very capable in the relationship and social stuff, but they're not very technically, I would say, adventurous. It was really hard for them to embrace this new technology. So we had to hire a technical person to support us there. So you know from Fahim before where Bangladesh is, but you don't know, these are the camps on the border with Myanmar and all the refugees. So as of, now these are the 2020 data. 2020, about 100 million refugees worldwide. Christina can correct me, maybe that's even more now. This includes Ukraine. And the reason I'm using this number is because the estimated that 8%, so that means about 8 million, live with disability. About half of them have physical disability, which means it's hard for them to walk and move around. And they live in a camp where you have to walk. There is no car, buses, light rails, nothing. And these camps don't have paved flat roads. And you'll see some pictures. It's muddy, it's uneven, it's uphill, downhill. It's hard for them to get access to basic things like food and get any health support. So the agency that gave us money, it's called Grand Challenges Canada, and the project is called Mobility Aid. So we propose to do it in these camps. This is more academic questions, so I'll go through them briefly. In this particular talk we were trying to do information communication technologies because that's what Fahim and I are. We have our research is in that, to assess the needs of refugees with physical disabilities. So the way I did this 3 sub-questions, so this is for the grad students, we brought that down into what's the role of ICT tools in evaluating the mobility and access, and how effective is remote assessment, and what are the key challenges in implementation. So I'm gonna, as I go through, tell you the answers we got to these questions. This is in a related work where we looked up what is the literature. In the literature review, there is a lot of human-computer interaction for development, but most of them is in technologies supporting low-income rural women in Bangladesh, literacy population, adjusting human-computer interaction for different settings, right? But since ours is about walking, we actually looked at the motion capture. And I don't know how much you know about motion capture, but it requires a room like this with 8 cameras and really fancy equipment and lots of technicians. It's expensive. So we tried to replicate that motion capture in the camp to see how they walk. And the gait means I'm walking and you're looking at my steps and I push off and the way so I don't know if you watch people with crutches walk, they walk differently, and you'll see the pictures. People with canes walk differently. People who have any assistive device work differently. Not much work is done in that space. Mostly on athletes, how they're moving on the court and stuff like that. There's a lot in the gait recognition. Now, there is this huge space, which not many researchers done, is as the population get older, you can predict from their gait actually their health. But that's a different branch. Now, so what our friend Sylvia pointed out, that we are actually doing a research that's intersection of refugees and disability. So that's our intersectionality. So the contribution from academic perspective is that we use this algorithm, OpenPose, which open source algorithm that captures the points on your body and reenacts this motion capture. Just by filming somebody, they can actually do that. So we did that and used it in the lab to test it, and then used it in the camp to see if these people are walking with the devices we gave them properly. So our contribution is mostly in the field work, doing remote evaluation of their gait, then to look at the challenges for access of these disabled refugees, what they are and how they've been addressed, if at all. And then we use 3D printers, and I'll explain to you what we use 3D printers for. So we use 3D printers in the lab in Korea, and then we replicated the whole thing in Bangladesh and gave them training on how to use the 3D printers, and that was an interesting experience. So I was recently in Copenhagen talking about this. At the end of the talk, everybody was like criticizing everybody else. And when I talked, they all like looked at me like, wow, you actually did something. You went to the field and did something, which is lots of researchers just observe and don't do. And it's not an intervention. It's just we supply them with alternatives.
Were you at ICIS?
Yes.
No.
Sylvia was there.
Okay.
And
Agreed.
but it was a special session. Anyway, they all said, yay. And I got the clap. And now we have to get this paper submitted. And the feedback is, oh, everybody clapped. Only how is that helpful? Anyway, so it's not, because when you have a conference paper, it's your initial work. When you have a journal paper, you have to improve on your conference paper, and people are, everybody else is criticizing, and they told me, oh, just good job. So, well, yeah. So,
That's great.
so This is about Rohingya people. They are refugees, mostly minority from Myanmar, and they are the most persecuted minority in the world. That is a UN definition. They had to flee their homes and escape the violence, and they arrived exhausted, sick, and injured. That's the thing, is lots of them had to walk, and lots of the male population had been shot. And many of them, Fahim met with them, had a serious injury in their leg. So currently there's 1.3 million people there. So our field study, so this is sprawl, it's a huge, and it's divided, if you look in the first slide, in many different sections, many different camps. So our implementation was done in 6 camps, 6 camp areas, all that by the local NGO. So they estimated for us that approximately 10,000 people have problems moving around. 10,000 people have problems walking. And Fahim was there, he told me it's really hard walking, even with 2 healthy feet, that he has is the people who have any injuries. So our goal was to monitor the gait and then see how we can adjust their crutches or canes to help them improve. So we look at the terrain, and we actually, there was lots of data collected by our local partner. They interviewed and talked to 100 people. And in a scheme of things, when you talk about sample size of 100, it doesn't seem too much, but this is 100 refugees that they had to go personally to their location and talk. You can't put them together. Now, it's also during COVID. Okay? So that's a lot of effort on their part to go to 100 locations and talk to 100 people to get their feedback. That's quite a bit. The problems they had is during rainy season, the terrain is muddy. So what we did in Korea, and you will laugh, we brought the mud into the lab and we made it wet, and we tried these crutches to see how they perform in the mud. The project just finished in December, and then I was gone, and I hope, and my guys will get the mud out of the lab. So our mechanical engineer actually designed different crutches. So we all wear different shoes in different weather, right? Flip-flops, sandals, sneakers, hiking boots, stuff. So what we did is we designed the bottom of the crutches, and we used the standard crutches because we don't want to, we did give all 100 of them a new pair of crutches, but we didn't want to change the design. We changed the design of where the crutch meets the ground. So it actually is appropriate for muddy terrain. So it doesn't sink in. So you'll see it's a little wider, it's a little more gripping. And then we, yeah, I have many pictures. So I keep going. I'm slow. And then we did that video evaluation. So we did lots of stuff. None of that perfect, but we started. So the goals of the project is remote monitoring. And maybe I should skip the signal to noise ratio. This is not mechanical, it's too much mechanical engineering part, because I have to finish by 1 o'clock. Right? So we use this open source software called OpenPose. It actually comes from Carnegie Mellon, where Fahim graduated, where I worked when I was in Rwanda. And since then, there were a couple other ones. They have competitions, which software will actually win. It's 250 points on your body, and it reproduces your skeleton and how you move. It's kind of cool. And but we wanted to see if somebody's stable or not. Now we can't predict the falls, but we can tell if they're stable. Now, we talk with people who study stability. So there's this point here on the back of you where they put sensors, and then anybody who is doing any sports, you always bend your knees, you get closer to the ground, right? And you keep this area stable. It was hard for us to monitor that, so we actually went with an ankle because on the crutches, your legs are swinging. So, and this is all swinging, so it's not a good measure. So how did we do it in Bangladesh, working with this NGO with, sorry, I forgot. So we needed to do several steps. So I divided this in the steps we had to overcome using this last 3 years. First step is our local partner, and we got them a 3D printer, the same as in the lab. So they were, when we were doing it, they were learning how to do it. And the NGO is called Young Power and Social Action. They're local Bangladeshi NGO, not international. Then we use 3D printer for a mold. So this is one mold that is, it's printed from plastic, and it takes a long time to print. I don't know if any of you work with 3D printers. It's like 19 hours to print one. Yeah, long time. So we didn't print the shoes, we printed the molds, and then we did low pressure, we injected them by hand, and that's how we built prototypes who they were testing. They were testing prototype. So we made prototype A and prototype B. We had 2 designs, and we gave it to them to see which one works better. It's just a user testing. So this is how it looks. This is poured inside, and it stays overnight. So we made 50 of those, 50 sets, to give it to the people to test. So you pour this silicone rubber material under low pressure by our hand, and then we made these prototypes. They will not last long. They're not made out of rubber, but they're good enough for them to test which design they like better. So it was basically A/B testing for the design. So this is how one design look, and this is how the other design look. So we first tested them in the lab. And what we did is we actually, where is the lab testing? Yeah, we brought these ladies and a couple other guys. These are polio survivors who use crutches all their life, and they actually tested these designs in the lab. But on them, we put sensors and video them to see how they work. Okay, so we tested in the lab, and then these are the volunteers in the camp. So it's one of the refugees that walks with the crutches that they tested it in the field. So lab testing, field testing. First, they did a baseline study. So this is the survey of 100 participants, but we could not do user testing all 100. And even, I don't know if anybody did here, user testing, you don't need 100 people to test on. We did it actually on 50, and we did it as a matched pairs, 25 and 25. So matched pairs, you match them by age, disability, injury, and stuff. And then you give one of them design A, the other B, and then you swap. So you control for everything except your design. So they can tell you which one's better. So we cut that down. So 50 of them used our design. And that lasted 4 months, from September to December. They did the user testing. So, and this was also 4 months, the survey. So they gave us feedback on these 2 designs. And this is what they had to do. We had 2 phone cameras set up, a right ankle, and they had to walk there with the crutches, and we filmed them in there. And then these 2 cameras actually merged. You feed them into software, and they make a 3D version, stethoscopic. Yeah, it's pretty cool. Now, this thing here, that was a whole, he's giving me a look. That was the whole, so why you need a checkerboard? They had to sink in, right? And the checkerboard has to be the right way orientation. So it took a couple iterations for our NGO in Bangladesh to actually project, and it has to be seen from both cameras for them to sink in. So Fahim worked on that with them. Okay, so here is one of the refugee walking. So can you see the checkerboard here? Right? So this is the front view, and this is the side view. So we were able to do that in the lab, and we were able to do that on the field to see their skeleton moving and how stable they are. So I talked about this. So this is our polio survivors. So they gave us initial feedback, right? How do they? But they use them in a different settings. They use them on the pavement. Although you'll be surprised how many non-perfect surfaces for walking are in Korea. It's recently developed country, and there is all these areas. There's a bumpy, uneven steps and stuff. Not accessibility is not the top priority in Korea. I'm sure here you can't build anything without the ramp and stuff. But so many of these people would use wheelchair, but the last mile is with the crutches, because wheelchairs will not go to certain locations. And they gave us a verbal feedback. It was interesting. Okay, so I will skip this because I thought you were more interested for the field. So this is what we did. I'll just tell you briefly. Signal to noise ratio, and if there's engineers here, they will know. So we calculated acceleration, first derivative, and we calculated jerk, second derivative. So you want to be walking fast, but you don't want to be your movement to be jerky. You want to be smooth and fast. So if you do signal to noise ratio, the higher you are, the better you are. It's smoother and faster walking. Because if you're jerking, it's unstable. And this concept came from mechanical engineering, that everything they design in mechanical is mechanical engineering. You don't want it to jerk around. Like the elevators, the machines, the cars, the trains, everything. So that was our mechanical engineering approach to it. We wanted to get that high. So these are some data of the results. So we looked at, for this, we only, Fakim was there for that. He filmed 6 refugees walking, 5 were injured, and 1 is amputee. And we look at the signal to noise ratio for them. So what you want to do is you want the difference between them to be large. They're going fast, but they're not jerking around. And it does sound like jerking around, but so, and then we compared that with our Korean lab results. And we found out that interestingly enough, the person who was amputee actually had a large difference between this. He was actually one of the better ones, the person who is amputee. Then if you are, and I walked on crutches for months, if you're a beginner, you're just kind of wobbling around. The better you get, the smoother you move, right? So the large difference, so this up here is acceleration, this is jerk. So you want a large difference between them. So this is Korean user that was really good, and this is Rohingya user. So the only conclusion we can get to this, yes, we can use this as a measure, and yes, we can use it in the lab, and yes, it's usable in the field. We still didn't figure out how to actually implement it there, but this was just the prototype testing. Is this a tool that can be used? So don't ask me how we're going to improve the stability. We just tested that it can be done. And that was huge, because we're talking about, I think, motion capture machine we're looking at, it cost $30,000, the whole setup. And this is two cheapo cameras. I don't know if, yeah. Here's Fahim using this camera and stand filming people. And 2 of them, and that you replace $30,000 setup. So the conclusion of our first sub-questions, yes, you can use the same tool, video recording, open source software to test the gait in the lab and in the field. So this is how it looks there. It was not perfect space, but we were able to do it. So that's our first conclusion. It's possible. We were tracking the ankle, and they were considering including the knee. The hips swing too much. Then we looked at other things because, so this was our main goal. And then we look at that. Actually, our main goal is the funding agency told us we had to estimate our deliverables. So we estimated we're going to do 400 people. We are going to test them. We're going to see which of the design is better. We're going to produce and implement it for 400 refugees for this. But then we looked as academics at all of the data we got, right? So we had a baseline survey of 100 people, prototype testing of 50 people, then video data evaluation. So we used all this data to improve our understanding and development on the field. And then on top of everything, Fahim was able to interview 14 people verbally. Now that was another issue in itself because he would translate from English to Bengali and then to their local language, which doesn't have a written alphabet. So everything had to be verbal and it's like lost in translation. We don't know how much, but he had good interpreters and we hope that. So with the questions about what's your origin of your disability, what are your barriers and challenges? What are the main issues? Because we made assumptions, we don't know what they're going to tell us, right? So in the baseline study, they had to answer questions, but here it was more open-ended. And then how do they adapt and compensate for it? And that was interesting. We wanted to learn from them. What do they do? So this is 100 people from the first baseline study. So here is one problem we encountered is 85 were male, only 15 are female. And you'll see some pictures. The females, it's even harder. We couldn't even film females because of their clothing. You couldn't capture, motion capture would not capture because of their clothing. So we had predominantly male participants, which means our user testing was skewed. But there was nothing to be done to include these people. They didn't want to participate. We came up later on other reasons, and we found out what the reasons, and we ended the project with this whole campaign trying to include more female participants and doing awareness campaign and talking to them and motivating them. And that was kind of towards the end of the project after we found that was the issue. This is the data from all these 100 people. Why do they use crutches? Most of them had an accident, war-related injury about 27%, and then diseases and road accidents. We put that as a separate for the general accident because there's quite a few road accidents. And I heard that from other people. I did something similar, not in this great detail, in Malawi with another refugee camp where I had a research assistant who went and interviewed people. Road accidents are big reasons why people there get injured. Many people fall 5 or more times in the past year. And that's an issue because if you're already injured in your crutches and you fall, then you're compounding all the health problems. Most of them do struggle with walking up the hill. It's really, can you imagine with the crutches how it's for them to walk the hill and then on the mud. And then one thing we didn't know beforehand is that there's no repair shop. So if something small goes wrong, they cannot fix it. So that's one thing that we're proposing is to organize a small repair facilities for them to replace a screw or do any repair, alignment, and things like that. How long do they walk? That was an interesting question for me. You know how we all like track our steps and how much we walk in an hour, 2 hours a day. These people walk for everything, right? They cannot. So most of them walk 30 to 60 minutes a day. So imagine with the crutches walking an hour. It's the problem we didn't attack yet is the underarm pain. That's a big one. We're working on that, or at least I'm. So about 50% of them walk. 20% walk more than an hour, and then 23 less than 30 minutes, and then there is others. So what was the result of our prototype? Our design B, where you see here, was chosen by them as the one that was more comfortable and helped them in that particular location. So we're not saying, so we're now actually talking about moving to a different location that's, for instance, rocky or sandy. It will be completely different design on the bottom. This is for a muddy location. So that's why the 3D printer comes into play. You can design a prototype for the particular location, test it, and then you can do large production. So this, what you see, the black one is our large production. Once we pick design B, then they produce 800 of them, 400 pairs. And we have this metal mold, which I don't know if I have a picture. So this is them installing it. I'll see later. This metal mold stayed in Cox's Bazar, where the refugees are, so that they actually can produce more. Once you make that metal mold, this is not by hand. This is no low pressure. This is a machine doing it. But this is rubber, actual rubber, not the soft stuff we tested on. Qualitative data was interesting, and we are still working on trying to classify that. It's 14 interviews is not that many to run any fancy software. Again, only one was female, and that was really hard in particular. So one thing we actually are trying to do now is to get more field researchers that are women going talking to other women. As you can see on the pictures, all the volunteers are guys. I gave a similar talk to one conference last summer, and somebody noticed, oh, everybody there are men, so why would women talk to men going and giving stuff away? So, origin of disability. So this is just the quotes from the people who've been shot or beaten up. Difficulty walking during the rainy. So these are the steps that I have to climb up. So it might be okay for you and me, but for people who walk with crutches are injured, it's not easy. So the rain season is problematic. They stay at home most of the time. Now, this is something that is a different issue, but it came up in these interviews, is that people steal from them because they need help. They give them their ration tickets and they just go away with them and take food. So that's another social problem that came up. So they ended up being hungry. Because they don't get money, they just get rations for food. And if you can't go on crutches and carry that, you have to give it to somebody. That's another issue there. Lack of medical care and accessibility to medical care is another problem. We're just looking at them dumping on us what are all the issues, and then we're going to move forward with that, talking more of a policy perspective. So conclusion for this two last questions. So I told you about the first one. Yes, you can do this. The second entry, 2 and 3, is what are the needs. First, for us, personally, for the project, is hiring the local technical experts to help with the NGO. NGOs usually don't have technical people. And this person was wonderful. he basically solved all their technical problems. He single-handedly made all of these prototypes. We send them some from Korea. Fahim carried in his suitcase some bottles of this rubber, liquid rubber, because that couldn't be mailed because it's a liquid. So there was all sorts of issues. So, and the other advantage is this local engineer actually had cultural skills, so he can do contextual interpretation. Because when our engineers in Korea were telling the workshop people there how to produce something, there was a mismatch. There was a mismatch. One of the mismatches that we use proprietary software, they wanted to operate. So we use CAD designs. CAD design is expensive. So that had to be translated and everything, but they were really wonderful. I mean, you got to watch some of the videos. I didn't put any how they're making it. They're really physically pressing on this and making the metal work out. Some of the tasks needed in-person support. If Fahim didn't go there and talk to the people, he would not find out some of the things. So one of the major things, and I don't know if that's later, is that the reason we couldn't recruit so many women is that in their culture, if a woman is disabled, she stays home. She's not to be seen out. It's kind of a shame thing. And that's not the only culture. I know some other cultures where disability is shameful, but particularly in women, for some reason. So we're talking about refugee, disabled, and woman. This is like three in that ripple intersectionality. So we start recruiting more women volunteers to help with the communication. And we got some good feedback from them. So right now we finished doing this campaign and awareness. And yeah, this is where disabled women stay at home and not allowed to walk. So from the humanitarian perspective, we did our job that the agency hired us, but from the cultural perspective, we really developed the tool that's good for men there and not women. It's only 15%. So, but in order to get feedback from these women, we need to get better communication with them. So there was, we were big on recruiting female researchers to go there and talk to them. They did give them. So in our dissemination of these 400 pairs, there were lots of women recipients. So from humanitarian achievements, the winning design B, we manufactured it and it was distributed. Now we also had to, and this is the requirement of Bangladeshi government, we had to give it to host community. So whatever innovations come in the camp has to be shared to the host community. So this NGO had a good relationship with the disability organizations in Bangladesh. So they were given 100 pairs and 300 went to the refugees.
Ask a quick question. Were they
Yes.
distributed free of cost, or was there a cost associated with the crutch distribution?
I'm
Was it
sorry?
free of cost, or where
Yeah.
it is free of cost?
And yeah, that was our requirement for the funding agency. Now, as every funding agency, they want sustainability, local production. So what we did is, and we just wrote that, is we trained the local person how to use 3D printer. We gave them the designs. He just filled the form for me. What is happening with that metal mold? There is a local workshop that can produce more. So if there's need for more, they can make more. These actually cost, for us, it's cheap. It's $2 per pair. Now, for these refugees, might not be. Yeah.
I want to let you finish first.
Okay. Well, this is kind of the end.